just as you did in the lab, it's important to figure out what is the digit that you must guess when you measure things like this. So here is a 9, here's 11. That means this must be 10. So between 10 and 11, there are 1, 2, 3, 4, 5 spaces on this instrument. All right, so between 10 and 11, there are five spaces. 11 minus 10, and there are 5 spaces. So that's 1 milliliter divided into 5 spaces. So that's 0.2. So that means every space here is 0.2. All right, so this is 10.2, 10.4, 10.6. You must measure at the bottom of the meniscus, which is right here. So this liquid level is between 10.4 and 10.6. So what does that mean? That means it's somewhere in between 10.4 and 10.6. What number is in between 10.4 and 10.6? You need to guess it. It's not printed on the instrument. So that is 10.5, right? So that's your guess, 10.5. With an instrument like this, where there is a non-1 spacing. So this spacing is not 1. It is 0.2. It is not 0.1. Do you know what I mean by that? So when the spacing is by something that is a decimal that is not 1, then you can't guess an extra digit. You are limited to the same decimal place as the spacing, the smallest spacing. Okay. Here, this is gonna be a little different for different problems. All right. Now, what about this? Here, I've got 20, 21, 22, 23, 24, 25. The smallest spacing here is 1. Okay, that's different from this. The smallest spacing here was not a 1, it was a 2, a 0.2. Smallest spacing here is 1, so that means I have to guess the next digit. Here's what I mean. I've got 20, 21, and 22. The bottom of the meniscus is in between 21 and 22. So, in between 21 and 22, the bottom of the meniscus, it's like almost exactly halfway. So I would say this could be 21.5 or it could be 21.6, right? Notice that you have to guess the next digit. All right? So the answer here would be 21.5 or 21.6. All right? How about this? This would be this would be a similar case, so nothing different there. How about this? So now this is a balance. You used one of these in the lab last time. What I need you to do is just write down all the digits. I need you to type all the digits. And I have problems like this in this homework because I've had students who would go to the balance and then write down 0.20, and then they would come back and they'd be like, oh, the mass was 0.20. But see, if you're going to use a balance, you have to write down all the digits, and the reason is if you write down 0.20, that means you're not sure if it was 0.204, 0.201, 0.200. None of those are, I mean, none of those are certain, meaning any of those are possible. However, when you measure with this balance, you know that it is 0.204. Not only that, you know it's 0.2040. The 0 at the end is significant because there's a dot. So you got to write down all the digits to get the right answer. Alrighty. Now, same thing here. Write down all the digits to get the right answer. Now, let's take a look at this analog dial here. We've got a 60 here, we've got a 70 there, and we've got an 80 there. Let's count the spaces between the 70 and the 80. We've got 1, 2, 3, 4, 5. All right, so between 70 and 80 there are 5 spaces. All right, so let's do the math here. So between 70 and 80 there are 5 spaces. So that means 10 over 5. Each space is worth 2. 2 what? 2 degrees Fahrenheit. Alright, so if each space is worth 2 degrees Fahrenheit, that means I cannot guess the next decimal place. That's not okay, because this is not a 1. Since this is not a 1, the best I could do is right here in the ones place. And here's what I mean by that. Here I've got 72, 74. So that's, I have the needle pointing almost exactly at 74. So that would be 74 degrees Fahrenheit. In the canvas, I think you would just type 74 space F. So you would just type 74F, right? Now, what if the needle were in between the 74 and the 76? What if the needle were like this? 1, 2, 3, 4, 5. So this is 80 here, and this is the 70, all right? So what if the needle were pointing right there? All right? If the needle were pointing right there, what would you call that? You would have to call that, so this would be 74, this would be 76. If the needle were pointing right there, you would have to call that 75. Now, I want you to notice that what you cannot do. You would not be able to call that 74.8. All right? The reason why you wouldn't be able to call it 74.8 is because there isn't enough room here for you to know this number with any reasonable amount of certainty. I mean, this digit here, the ones place, is already uncertain. The reason why the ones place is already uncertain is because every space is 2 instead of 1. So there is some uncertainty in the ones place already. So you can't go do the tenths place, right? Let's try another one. Here's one. So 35, 30. Okay, this is easy. Every one is every smallest space is just 1 degree Celsius. So that's easy. Here's one that's harder. Excuse me. So this is 16, this is 17, and this is 18. All right. So every space is 1. Okay, now if every space is 1, that means you do have to guess the next digit. So this is 16, this is 17. You have to guess what this would be. It isn't 16.5. It's a little bit before 16.5, so I would say it's 16.4. If you type 16.4, 16.3, I think you would still have the right answer. I think you might even have the right answer even if you type 16.5, but I would say this is 16.4. Notice I had to guess the tenths place, the next digit. One more here. Now this is, I know that you've used rulers before, but the way you use them in your ordinary life is not the way we use them in a science class such as chemistry or even physics. So here, let me see. Let me get a straight edge here. Here's a straight edge here. So I'm going to use this edge to see where exactly the point is. The point is just before the 16. Do you see that? The point is just before the 16. It's not on the 16. It's just before the 16. So what does that mean? That means that we're going to have to guess the next digit. So this is a 15 to 16. The spacing here is 1. So this is about 15.9. You would call this 15.9. If you called this 16, that would be wrong. If you called it 16.0, that would still be right, because the last digit is an uncertain digit. It is a guess. So 15.9 would be okay, and 16.0 would be okay. 16 would not be okay. You see, there is a difference in science between the number 16 and 16.0. 16 means, it could have been something like 15.5, it could have been 15.9, it could have been 16.4, it could have been 16.3. All those things mean 16. However, 16.0 does not mean any of these things. Do you see that? So that's the difference. It's a difference in precision. So that's how you do this work, and that's how you do measurements in the lab. Thank you.